Welcome to the lesson on the ANS system of the nervous systems. So what we're going to do is we're going to start with a dad joke, of course. This dad joke is going to be that I lost my mood ring a couple weeks ago, and I still don't know how to feel about it. And that's because mood ring was supposed to tell me how I'm supposed to feel about it. But moving on, we're going to go ahead and dive right into the essay question. This first one says, compare and contrast the sympathetic division of the ANS, parasympathetic division of the ANS, and the somatic nervous system. So we're going to go over here to this little chart that I drew out, where it talks about, it just dives into the deeper. So with the sympathetic nervous system, it's going to be your fight or flight response. It's going to be responding to a bear. It's going to be like running from a bear or fighting it, depending on your response, which is also in the thoracic cavities where the neurons come from. And that's from T1 to L2, as you see over here. And the synapses have a preganglionic neuron that is going to be short and a postganglionic neuron that is going to be long. So short, pre, long, post. Then within there, you have different nerves or subdivisions, which the sympathetic nerve synapses in the chain ganglia and it goes from T1 to L2. And then, and just to show you a little bit of what that looks like, is you're going to have your spinal cord here, and then you're going to have your preganglionic neuron there, and then its synapses in the chain ganglia. And then you have your postganglionic neuron, which then synapses in everything above the diaphragm, which is the heart, the lungs, and things to that caliber. Next, we have our spinal nerve, and that's going to be also synapse in the chain ganglia, but it's going to, the pre is going to come from the T1 to T5. And so it's going to only come within an area up here. It's not going to come in this bottom area. Whenever that happens, it's going to come and synapse in the, we're going to change this color here to show the spinal. So the spinal will come, synapse in here, and then it will go to the like blood vessels. It'll go to your tears. It'll go to your skin. I don't even know how to draw skin, but I'll just draw a hand. So the skin, and like for sweat and things like that. Then your sphincteric nerve is going to go through your collateral ganglia. So it's going to, we're going to draw this one in blue. It's going to go through, through your chain ganglia, then synapse into your collateral ganglia. And then your post is going to synapse in everything below the diaphragm, such as like your kidney system, digestive system, ureter, things like that. And there is a special sphincteric nerve that we'll draw in green that's going to come up through the chain ganglia, through the collateral ganglia, and into the adrenal medulla. And it's going to release acetylcholine that will cause the release of epinephrine once it reacts with the effector organ, which we'll get there and we'll talk a little bit more about that here in a minute. And with this, the sympathetic nervous system has 2 neurons on each one. The parasympathetic is similar, has 2 neurons, but your parasympathetic is known as your rest and digest. That means that whenever you're calm and like relaxed state, that's going to be the what you'll be experiencing. And so with this, you have a long pre-ganglionic neuron and a short post. And this is on nerves 3, 7, 9, 10, and S2, your sacral 2 through your sacral 4 vertebrae. And on number 10 in the vagus nerve, 75% of all nerves are on that sacral nerve. on that vagus nerve. And then with this being stated, it synapses at the effector organ. So it's going to travel there and synapse there. And it's going to control all these, such as the lungs, heart, kidney, stomach, pancreas, intestinal tract, liver, ureter, things that will help you be relaxed. The targets that each of these are going for is the smooth muscle, cardiac, and the glands. Next, we're going to talk about our somatic nervous system a little bit. And so the somatic system is one neuron, and it doesn't have doesn't synapse in any ganglia. It just goes straight to the skeletal muscle to innervate. And then just talking a little bit about sensory here is you're not going to have any subdivisions in the sensory, but it will synapse in the spinal cord, the neuron will. And whether or not and the sensory will tell your brain to respond to a different change in things, especially in your heart. Like along your aorta, it'll say whether it's tense, the muscles or skin around it, tissue around it, will say whether it's loose or tense, and that will tell the brain to make a specific response based on the sensory, even if you have a lesion down past that sensory organ that controls something else. You just wouldn't feel the pain if the lesion was blocking up an area past that point. And then, so with this, we're going to talk about a little bit more in the receptors on each. So with the sympathetic nervous system, our receptors are going to be alpha 1, alpha 2, beta 1, beta 2, beta 3, dopamine 1, dopamine 2, nicotinic 1, and nicotinic 2. Mainly just your nicotinic 2. And acetylcholine is going to be your pre-neurotransmitter, and norepinephrine is going to be your post-neurotransmitter. Then we're going to move over, and real quick, just touching on what an adrenergic and cholinergic receptors are. Adrenergic is these are, I see what I was doing. Your adrenergic is anything that synapses that receives catecholamines, such as like norepinephrine, dopamine, epinephrine, while your cholinergic are going to be receptors that receive acetylcholine. With this being said, the sympathetic receptors, the alpha 1, the alpha, beta, and dopamine, are going to be adrenergic because they're going to be receiving that norepinephrine from the post-neurotransmitter. Sweat glands are an exception, as they do fall under the sympathetic system, but they have M-odd receptors. And so therefore they will be cholinergic receptors. So parasympathetic receptors are M1 through 5, and that's going to have the acetylcholine in the pre-neurotransmitter and acetylcholine in the post-neurotransmitter. And with that being said, because it reacts to acetylcholine, that means it's going to be the cholinergic receptor. And then we're going to move on to our somatic receptors. These are what we call our nicotinic receptors, which are generally made up of N1 because that's our voluntary control of skeletal muscle. And acetylcholine is the neurotransmitter, making this a cholinergic receptor. Next, we're just going to make sure that everybody has these memorized. Is our alpha 1 is going to control our blood vessels. Our beta 1 is going to control our heart. Beta 2 is going to control our lungs. Beta 3 our fat, and our muscarinic odd is going to control our generalized sweat glands. Now, with this being said, there is something important that we need to know with that I'll also reference later, is the evens will send out an IPSP, while the odds will send out an EPSP. We'll touch on that a little bit more in the future, basically saying evens are going to cause muscle to relax, odds are going to cause muscle to constrict. Now, moving on to this next part over here, we're going to talk a little bit more about the anatomy of the neuron and how it moves. As you see in our little diagram here, a solid line equals myelinated, a dashed line equals unmyelinated. So first we have our preganglionic neuron right there, which when an action potential moves down this neuron, it's going to cause the release of acetylcholine. This acetylcholine will then bind to a ligand-gated cation channel, which is going to allow cations into the cell, which is usually a nicotinic type 2. It's also ionic, tropic. And that is then going to cause an action potential to sweep down this neuron, causing a release of a different neurotransmitter, which is the norepinephrine. This norepinephrine will then bind to an effector organ, which is going to be either smooth muscle, cardiac muscle, or gland. And so, which we know from it being the sympathetic pathway because it's a short pre and a long post, then it's going to be alpha 1 through D2. So something important to know just about the receptors real quick is that alpha 1, M1, M3, M5 are all G proteins, and they work with IP3. And because they're odd, they're going to excite, cause an EPSP. Alpha 2, M2, M4, D2 are going to decrease CAMP, and because they're all even, they're going to cause an IPSP. And D1, B1, B2, B3 are going to increase CAMP. And all of these will cause an EPSP because they're odd, except for B2 here. That's going to cause an IPSP because it's even. And so with this a little bit is whenever the ligand binds to the GPCR, it's going to then activate an alpha receptor, which is then going to cause it to react to a secondary messenger, sending a signal down to cause a different response. So that's just some of our target organs right there. It's going to affect ones based on the target organs it affects up here. So then moving on to our next one, we're going to talk a little bit about a parasympathetic ganglion. So we can tell because it's a long pre and a short post. And the preganglion is going to release acetylcholine, allowing it to bind to the ligand-gated cation channel of nicotinic type 2 receptor. And then it's going to cause an action potential to sweep down the neuron, releasing. And then with the parasympathetic, it's going to actually release more acetylcholine as the neurotransmitter, which then is going to react with M1 through N5 to turn on or off the target effector organ. Make sense? Sweet. So we're moving on. Next, we have a special sympathetic neuron that we want to talk about. This is the one that goes to your sweat glands. So we have a short pre, long post, right? It's going to release acetylcholine just like normal in the pre, and then it's going to allow the action potential to take place going down the neuron, and it's going to release more acetylcholine in the post, which that will then bind to an M-odd receptor, allowing your sweat glands to be activated, meaning you're going to start sweating more. And so that's special because it has acetylcholine in your pre and your post. Next, we're going to talk about another special one in the splanchnic nerve, which goes to the adrenal medulla. And so with that there, it's going to go all the way to the effector organ, through the chain ganglia, through the collateral ganglia, to the adrenal medulla, and it's going to release acetylcholine. That acetylcholine will then react with the effector organ. I made this look like it's a post, but it's not. It's just an effector organ. And that's going to cause the release of epinephrine, because that's what the adrenal medulla does, is releases epinephrine. and it's going to release that into the bloodstream. And so, and that epinephrine will cause different responses whenever it hits different organs. With this being said, I just want us to understand what a catecholamine is. A catecholamine is either norepinephrine, an epinephrine, or dopamine. So anytime you see any of those, know that that's what that is referring to. And so real quick, we've talked about our nervous system. We know that our central nervous system is consisting of our brain and our spine. Our peripheral nervous system is consisting of our somatic nervous system and our autonomic nervous system. Our somatic nervous system consists of our sensory neurons and our motor neurons, which control like how we feel things and motor and our ability to control our muscles. And then we have our parasympathetic nervous system and our sympathetic nervous system, and talked about that a little bit there. So next we're going to go through this just to make sure we got everything covered. So we talked a little bit about including the things such as the CNS origin. We talked about the number of neurons in the pathways, the location of the ganglia. We talked about the neurotransmitters, types of receptors, and their actions. We discussed the cholinergic and adrenergic receptors. We explained the different subdivisions of each type. And then I'm going to go through giving mechanisms of action for each type of receptor and what happened when the neurotransmitter binds to the receptor. So that's going to be this here. So here, I'm going to walk you through what happens with the sympathetic versus parasympathetic on the inner sphincter of your anus. So, when I want you to think about it like this. Whenever you have your sympathetic, you are fight or flight. So whenever a bear comes along and chases you, what's going to happen to the inner sphincter of your anus? Are you going to poop your pants more? Or are you going to hold that poop in and run? You're going to hold that poop in and run. That's right. So that means this inner sphincter muscle is going to contract. That means it's going to have an EPSP occur. So I just want to talk about that a little bit there then. Now we're going to move to the parasympathetic system. This is your rest and digest system. So whenever you're resting and digesting, you're more likely to poop. So that means it's going to relax, allowing you to poop more, sending through an IPSP, allowing that inner sphincter muscle. Next, we're going to talk about the neurotransmitters released. So when in the sympathetic pathway, we always know that this first neurotransmitter is going to be acetylcholine, and then this post neurotransmitter is going to be the norepinephrine. With the parasympathetic, we know that they're both going to be acetylcholine. Now, what we want to do is talk about the receptors. So sympathetic, we know that our options are going to be alpha 1, alpha 2, beta 1, beta 2, beta 3. And the reason why I'm not listing dopamine 1 or dopamine 2 is because those go to the brain. So we can automatically cross those out. Now, we know that we want to contract our inner sphincter muscle. So we can go ahead and take out the ones that are going to give an IPSP, which is beta 2 and alpha 2. So now we know that the receptor here is going to be either alpha 1, beta 1, or beta 3. But we also know that beta 3 goes to fat. So we know that we can cross that out. So we know that it's going to be either alpha 1 or beta 1. Then with our parasympathetic rest and digest receptors, we know it can be M1, M2, M3, M4, or M5. We know that we want to relax, causing an IPSP, so there we can cross out our odd numbers. So now we know that our receptor is going to be either M2 or M4. So that's going a little through the mechanisms of each type of receptor and what happens when the neurotransmitter binds to the receptor is it's going to cause a different response based on what your effector organ is. Such as the lungs, if we change this to the lungs, we already know that it's B2. I'm just going to erase some things here. We already know it's beta 2, but we'll walk through the process for both. With the lungs, when you're fighting or flighting, you want to breathe more. So you're going to want to relax those lung muscles, causing an IPSP. And look at that. Beta 2 is doing that perfect. When you're resting and digesting, you don't need to breathe you don't need to take in as much air. So you're going to contract, also known as having an EPSP. So with your fight or flight response, you're going to send the acetylcholine down and then causing another action potential of releasing norepinephrine, which is going to cause an even number to cause the lungs to relax. Now with so you generally, that's why I don't want you to memorize sympathetic is causing you to contract and parasympathetic is causing you to relax, because sometimes it's reverse. So with that also being said, the parasympathetic pathway is going to come down. We know it's going to be M1, M2, M3, M4, or M5. But we know that it's contracting, so we can take out M4 and M2. So we know that the receptor is going to be either M1, M3, or M5. And I just happen to know that it's M3 for sure. But if you can get to this point, that's all we need for that's all they're going to test you on, or make sure that you understand. So now that we gave the mechanisms of action for each type of receptor and when the receptor binds to it, I hope you guys have a great rest of the day, and I do want you to end on a dad joke. So I drank a bottle of invisible ink, and I went to the hospital to get myself checked out because I didn't know if it was toxic, and it took a long time for them to see me. There you go. All right. Have a great day.